Hey y'all, Miss Mayhew here, and today I'm going to review the sodium-potassium pump with you guys. So what you have here is a diagram of the sodium-potassium pump, which is a protein pump that is embedded in the membrane. In the first diagram, we have a picture of the sodium-potassium pump that is open to the inside of the cell and closed to the outside of the cell. Whenever the sodium-potassium pump is in this position, it has a high affinity for sodium. That basically means that it really likes the sodium. It's shaped in a way that the sodium fits in it really well. So those sodium ions, along with an ATP, are going to bind to the sodium-potassium pump, which leads us to image 2. When that ATP binds to the site on the sodium-potassium pump, that causes a conformational change in its shape. That causes it to open up to the outside of the cell. Now, why this is important is because it leads us to image 3. Whenever the sodium-potassium pump is phosphorylated, it changes its shape so that the affinity is now not towards the sodium. That sodium is released. It now has a higher affinity for the potassium. So now it's shaped to where the potassium binds. Then, when my potassium binds, that causes another conformational shape change, which releases the phosphate group and opens it back up to the inside of the cell. This cycle repeats over and over again.